Is that something that we can link these two equations together? Okay, there is how are they related? Through their roots, right? It seems like there is a relationship. Okay, so for questions on sum and product of roots, first thing we should do, what is it? What do we write?
Find the negative b over
Okay. Write down the sum of roots, product of roots, isn't it? So first equation from equation number 1. Sum of roots, meaning alpha plus beta. What does that give me?
negative b over a.
What is b?
A.
Negative.
Oh.
Negative of negative a, isn't it? Okay, so be very careful. Negative of negative a over 2. Okay, so alpha plus beta equals to a over 2. Now, what about the product of roots? Alpha, beta. 3 over 2. Okay, now from equation number 2, sum of roots. What does the sum of roots give us? What do I write as the sum of roots? It is always something equals to something, right? Okay, in this case, I know it is going to be equal to 52 over 9. Okay, but what is this over here? 1 over alpha square. Okay, 1 over alpha square. 1 over alpha square plus 1 over beta square. Okay? Do you all like the expression left like this?
No.
What do you want to do?
Expand. Factorize.
Try it. Combine the fractions? Okay, let's combine the fractions. So beta square plus alpha square over alpha beta square equals to 52 over 9. Do you prefer this? Why do you prefer this?
Sum of roots. Sum of roots. You can put the product roots.
Okay, product of roots at the bottom already, right? What about the numerator? Do you like it this way?
No.
What do you prefer to change it to? Alpha square plus 2 alpha beta plus beta square, then minus 2 alpha beta in the numerator. Do you prefer this? Yeah lah, isn't this what I'm doing? Look at this one over here. I got plus 2 alpha beta and minus 2 alpha beta, right?
Because it will make it
Okay, let's just compare the numerators for these two fractions. Alpha square plus beta square. Are you able to get the value of this alpha square plus beta square straight away? Don't have, right? We only have sum and product of roots. But what about this sum of squares? Alpha square plus beta square. Not, I don't have the value straight away. But there's a workaround. And it happens if I were to introduce 2 alpha beta. Then I subtract away 2 alpha beta. Now effectively, does that change anything to the numerator? No, it doesn't. Because you plus something, you remove the same thing, nothing happens. But by doing so, if I combine these three terms, if I combine these three terms, what do I get?
alpha plus beta bracket square.
Yes, alpha plus beta square. Alpha plus beta square. Now, do you prefer it in this format now?
Yes.
Why?
Because a product of the sum of root alpha and beta then square.
Okay, so we have the sum of roots, we've got the product of roots already, right? Okay, and these values, alpha, beta, alpha plus beta, they are found on this side. Okay? Yes?
Just to confirm.
Yeah?
The alpha and beta from both equation is square.
No. This alpha over here, oops. This alpha you see over here is the same alpha over here. It is the same question. They cannot use the same letter to represent different things. So when they say alpha in the same question, all the alphas are the same. Okay? Okay, now we also have the product of roots for the second equation. So again, from equation number 2, product of roots, that will be 1 over alpha square, 1 over beta square. That should give us 4 over 9. right? So this is actually 1 over alpha beta square equals to 4 over 9. Okay, with all this information, our goal is to find the unknown, which is found here. You see that everything else is, all our sum and product of roots, we've got a value. Except for that one, alpha plus beta, that is a over 2. Okay, what do you think I should do next?
Sub in.
Yeah, let's sub in whatever we can and let's see what happens, huh? Okay, what would you like to sub in? Which one into where?
Product of alpha beta.
Okay, so this one goes where?
Into the below part.
The blue one?
Yeah, the blue one.
Okay, the blue one. So this one goes here, right?
Yes.
As well as here. Okay. So in my new equation, I will only have the yellow part, which is highlighted, which I don't know what is it. I'm going to be replacing the light blue portions with numbers, and it is going to be equal to a number. Does that make you happy?
Yes.
Yes, right, because we are getting rid of some unknowns already. What else do you think we should do? We are still not answering the question. I want the value of A.
Sub in add alpha plus beta into the yellow part.
Is that here?
Yes.
Can you visualize what's going to be our end product? You're going to get one equation with how many unknowns?
1.
1. What is that unknown?
A.
A. Can you solve it yourself?
Yeah.
Can I also don't need me to show you already, right? Okay, so this part, apparently it is redundant. We didn't have to do it. It was useless to us. But, is there a second part to the question? Oh no, there isn't a second part to the question. So yeah, that's it. Okay, you'll be able to find A. Can? Sub in, then you only get one equation with one unknown. And find the value of A. Okay, come next question. I don't want to spend time in class for your trying out questions. I want to go through approaches. Yes. Okay, mentor series, page 17. Which one? Question 10. When x cubed plus 2px plus 2 divided by x minus 2, remainder is 3 more than remainder when expression divided by x plus 1. Okay, find p. Thank you. Okay, so we have this question in your mentor series on page 17, question 10. Approach. Okay, let fx be equals to x cubed plus 2px plus 2. That's my first step. Now I need to translate the question into mathematics. First piece of information, when it is divided by x minus 2, remainder is 3 more than something. Okay, let's go on to the next part. When it is divided by x plus 1, it has a certain remainder. Okay? Let us find out what we can get from these two pieces of information. Okay, let us start with the green color part. When it is divided by x plus 1, what is the remainder? When fx divided by x plus 1, remainder equals to f what? Remainder theorem. Your test tomorrow. F of -1. Right? This is our remainder theorem. Okay, this one. Very basic. Okay? So straight away I can get a remainder. That is -1 cubed plus 2 times of p times -1 plus 2. This is -1 minus 2p plus 2, which is 1 minus 2p. Correct?
Yes.
What is the remainder?
1 minus 2p.
Do you know the value of p?
Yes.
Don't know yet, right? Okay, so quite stuck. Never mind. Let's see what else did they say. When fx divided by what now? X minus 2. Remainder Let's find out what it is. Equals to f of 2. Okay, that gives us 2 to the power 3 plus 2p times 2 plus 2. So that is 10 plus 4p. Correct? What else did it tell us? Which one is 3 more than which one?
The first one, the f of 2 is 3 more. So 10 plus
Oh, wait. F of 2 equals to f of negative 1 plus 3, is it?
Yes.
Let me check. It's divided by x minus 2. The remainder is 3 more than, that is correct. So are you ready to sub it?
Yes.
10 plus 4p equals to 1 minus 2p plus 3. One equation, one unknown. Can solve not?
Yes.
Surely you can. So 6p equals to 4 minus 10, which is negative 6. P equals to negative 1. Is it correct, Kevin? Is that the correct answer? I didn't tell you to focus on this, right? Did I? Is this one of the questions that I encourage you all to do?
No.
It's not.
No.
Okay, but it's a good question. Okay, so these two are factors of fx. What can you tell me about fx when they tell you they are factors, right? What is the first thing you should do? No remainder. Okay, so remainder is given by f of something that is equal to 0, right? So when you say no remainder, it means the remainder is 0 lah. Am I right? So f of what equals to 0? Negative 2. What else? F of 4 over 3 also equals to 0. Is this something that we can work on already? Yeah, okay, let's do that. 6 times of negative 2 power 3 plus p, negative 2 square plus q, negative 2 plus 24 equals to 0. That's the first thing. So expanding it out, negative 48 plus 4p minus 2q plus 24 equals to 0. Okay, 4p minus 2q minus 24 equals to 0, 2p minus q minus 12 equals to 0. That's from the first piece of information that said that x plus 2 is a factor of fx. I see it is one equation with two unknowns. Can I solve it?
Not yet.
Not yet. I need another equation with the same two unknowns. Then I can solve it. Okay, let's do it next. 6 times of 4 over 3 cube plus p. 4 over 3 square plus q. 4 over 3 plus 24. Again, it is equal to 0. Because no remainder. 6 times of 64 over 27 plus p 16 over 9 plus q 4 over 3 plus 24 equals to 0. Okay, let's do some simplification. This one becomes 3.
38, 2 over 9.
Huh? Wait, what? The first one, okay. Tell me, how much is it?
The first one, the last one is. The first one is 14, 2 over 9.
I want improper fraction. I don't like mixed fraction. 128 over 9. Is that for the first fraction?
Yes.
Okay, then plus 16p over 9 plus 4q over 3. Is that still a plus 24?
Yes.
Okay, plus 24 equals 0. Simplify. Come on, quickly. Actually, what will you do from here?
Times the 3 there first, so you make it 12q, and then times 9.
Times 3 becomes 12q.
Oh,
Everything times 9. Everything times 9, right? Okay, so 128 plus 16p plus 36q. Oh, wait, this one only times 9, right? Some times 3, yeah? Okay, some times 3, we get 12. Plus 24 times 9, how much is it? 216 equals to 0. Okay, next. 16p plus 12q plus how much? 3, 4, 4. Is that right? Okay, simplify. I don't like such big numbers. Divide by. Can I divide by 4? Can I divide by. Yeah, I can divide by 4. So 4p plus 3q plus 86 equals to 0. Okay, two equations. So a bit tedious lah. So two equations with two unknowns. Equation number 1. equation number 2. Okay, who asked me for this question? Do you get these two equations? Okay, so do you know how to solve these two equations?
Yes.
Can Okay, tell me what's P and Q. Don't want to waste time
P is negative 5, Q is negative.
Okay, P equals to -5 and Q equals to -22. With this, the next part of the question says solve fx equals to 0. Now look at this. This is our fx. Did they say in the original question that it is equal to 0?
No.
No, right? It's only this part, the final part, then it says solve when it is equal to 0. That is when we put fx equals to 0. Okay, let's sub everything. So substituting P and Q into the question, what do we get? Please,
Mr. Wong, what are they actually asking? I'm not sure.
Okay, wait. Now we found P and Q already, right? Let us substitute it back into the equation. Fx equals to, okay, read it out to me. Ayah. Okay, 6x cubed plus px squared. How many memorize?
6x cubed plus
6x cubed plus px squared. Okay, I don't want to write p. I'll be writing -5. -5 x squared. Then what? Plus qx plus 24. Okay, now this is fx. Can so far? Now there's another question. That is, when this is equal to 0, they said when fx is equal to 0, find the value of x. Okay, so this is what I'm going to do. This is equal to 0. How are we going to solve it? This is a cubic equation. How do we solve cubic equations? Huh? What ABC?
No, I thought you just find one vector. You guess the make it 0.
Did I make it 0 already?
So you guess and check.
Put a factor outside and after that you do
Guess and check one factor. Is that it? Is that the approach I taught you all? Yes, it is. Is that the only way I taught you all?
No, I forgot. Long division.
You long division, you must divide by something, right?
and then that's the only way.
Yes, that is the only way. When you are asked to solve a cubic equation, I hope this goes in your
No, 3, 4.
brain. You will need to guess and check the first one, the first factor. Okay? And guess and check sometimes can be tiring. If you are unlucky, you keep guessing the wrong one. So what's the better way?
Mode 3, 4.
Okay, mode 3, 4, you get a certain value. Choose the integer. Can you do your mode 3, 4 now and tell me what would you like to substitute?
Negative 2, x equals negative 2.
So you want to substitute -2 here or you want to substitute 2 here?
Negative 2.
-2 Okay, let's try lah. 2 or -2? Yeah, -2 also integer. So sure, you want to try 2
Negative 2.
Okay, -2. Let's try. We are now trying to find a factor. 6, -2 cubed, -5, -2 square, -22, -2 plus 24. Let's see what this gives us. What do we hope to see?
0.
We hope to see 0. Okay. So -48 minus 20 plus 44 plus 24. 0. Am I right? Oh, -2. So this is equal to 0. Am I right? Yeah. Okay. What can you conclude then?
X plus 2 is
It's a factor of the equation.
Of fx. Okay, what's the point of having this? If it is a factor, that means I can take fx divided by x plus 2 and then I'll get something here, right? Which means this one will be known as the quotient, right? Which means fx can be written as x plus 2 times the quotient, right? Whatever the quotient is. And since this is equal to 0, that means that x plus 2 equals to 0 or the quotient equals to 0, isn't it? And then this one you can solve, right? What do you think the quotient looks like?
quadratic.
Quadratic. How do you know it is quadratic?
Because you look out power.
How do you know it's quadratic? Because fx is cubic. When you divide a cubic by linear, then the power drops by 1, right? The degree drops by 1. Therefore, we end up with quadratic. So, if you were to do long division, you will you will get the next part, meaning ax squared plus bx plus c equals to 0. That is the quadratic portion, isn't it? Okay, so this portion, do you know how to solve quadratic?
Yes.
Are you sure or not?
Yes.
Some of you don't even know how to substitute properly into quadratic formula. You didn't memorize your quadratic formula for your EMAS test. So you lost 3 marks. Then, some of you tried to factorize, but cannot factorize. So you use your calculator to help you, and then you pretend that you can factorize, oh, x minus 2.14592, x plus 6.7815. You think I believe you actually tested this out? Obviously, you got it from calculator, right? So even if you got the correct answer, you still get 0. So what should we do? If it cannot be factorized, then what should we do? Use the formula. Is the formula provided to you?
No.
Then what must you do? Memorize. Have you memorized already?
Yes.
If you cannot memorize, then what should you do? You derive it. You derive it yourself from completing the square. Do you know how to complete a square?
Yes.
No, not everybody knows how to complete a square. So some of you tried, desperate already, complete a square. Can't even complete a square properly. Wasted your own time. Okay, so enough with the scolding. If this can be factorized, then very easy. In fact, your fx is going to be equal to 0. So you can find the values for x. Now sometimes we cannot factorize it. So we will need to do x equals to, since this part is equal to 0, x equals to minus b plus minus square root b squared minus 4ac over 2a. Sometimes this gives you 2 values. Sometimes it doesn't give you anything. Then we will only have one answer. Okay? So this is the approach by long division. Now what if I don't want to do long division? By observation, okay. So now we will need to rewrite fx. Fx now equals to x plus 2. It is a factor, right? And this is my quotient. What form is it going to be? Ax squared plus bx plus c. And let us compare this with the original fx, which is 6x cubed minus 5x squared minus 22x plus 24. Okay, from here, which of these unknowns is very easy to find out? Okay, so by observation, a equals to 6, c equals to? Sure not. So how much is it? 12. Can do it straight away? Can Okay, we are left now with b. What should I do? What do you want to set x equals to? What do you want to set x equals to? You can choose anything you like.
0.
Okay, 0 sounds good. So we get 2 times, no, 0 doesn't sound good.
Oh yeah, because you
Y, okay, so this will give me a times 0 plus b times 0 plus 12. That it doesn't work already lah. Okay, because I want to find b. So 0 doesn't work. What should I do? Okay, let's try 1. 1 plus 2? Yeah, okay, fine, 3. So this is 3. Then a is 6, right? 6 plus b times 1, b plus 12. Am I right? Okay, so this gives me 3 times of b plus 18. So this is 3b plus 54. Correct? And then what's the point of doing this?
make a find b lah. So
How to find b now?
another equation.
Really, I need another equation.
So what I do is I move the
3b first is equal to 0 already. So just do 3b. 3b
Huh?
equals to negative 4. 54.
Wait, why 3b equals to negative 54?
First say 0 already.
What do you mean it says 0?
Say bracket x bracket is
Yeah, f bracket x is 0, but doesn't mean that x equals to 1, right? Now I randomly chose a value of x which is 1 inside here. So now you're very happy, know how to substitute. Then what do you do with this?
huh?
The objective was to find b, right? So you're substitute already, so what's b? What's b?
Negative 54 divided by
Why? Are you telling me that 3b equals to negative 54?
Yes.
Why?
Actually not.
Why would it be?
Because it's not a vector. It's not a vector.
No, is it not? Isn't it not a degree?
You see, if you tell me that 3b equals to negative 54, you are trying to tell me that 3b plus 54 equals to 0, right?
Yes.
Why would that be so?
Because the question said.
What did the question say? What did the question say? They said solve fx equals to 0. Did they say f1 equals 0? Your job is to find the value of x such that it is equal to 0, such that fx is equal to 0. Am I right? Now you randomly choose a value of x which is 1. And you think that by substituting it into the fx, it gives you 0. Where's the logic in that? You are supposed to find the value of x such that it is equal to 0, not randomly choose a value of x and say that it is equal to 0. Okay? So, this part is still correct, but what is the point of finding 3b f of 1? I think some of you know the answer already. So what's the reason? f of 1 is 3b plus 54. How do I make use of that? Yes. Into the original equation, right? What happens if you do that? F of 1 equals to 6 times of 1 cubed minus 5 times 1 square. Okay, I don't want to waste time already. Plus 24, right?
Yeah.
Does this make sense?
Yep.
Okay. This is 6 minus 5 plus 2, which is 3. Okay, what do we conclude now? 3b plus 54 equals to 3. Okay? Make sense?
Yes.
So you can solve for b. Then put it back here. And you now have the quadratic expression, which you could have obtained using long division. They are supposed to be the same. Then solve. Okay? This is recorded. You can go and watch it. Next question. Okay, now listen. Approach for this one. What is the approach? What is the approach?
Partial fraction.
How to straight away do partial fractions?
Divide first.
Cannot.
Why need to divide first?
Because they are improper fraction.
Okay, so this is improper fraction. How do you know it is improper fraction?
Because the
Because the power is higher.
higher than the power below. It's the same as the power below. It's the same.
Okay, listen. The degree, okay, the highest power is the same as the degree over here, right? 3 and 3. So it is improper. So since it is improper, what do we need to do? We need to do long division. Let us do our long division. So something divided by something, okay. 2x cubed plus 0x squared plus 0x plus 3. Is this how you do it? Yes, okay. Then the denominator, we've got 2x cubed plus x. Okay, so do our division. 1. So 2x cubed plus x. Minus it off. We get negative x plus 3. Can I divide some more? Can? Or so stop already, right? Okay, this tells me that this is equals to 1 plus
Negative x plus 3
over
x.
x.
2x squared plus 1.
Okay, are you all able to do this?
Yeah.
Really are? Your long division algorithm since primary school. Same thing over here. This one will give you 1 mark already. Okay? Now, is this a partial fraction yet? No, it is not. I haven't split my denominator, right? So what am I expecting? 1 plus a over x plus b over or bx plus c. Why? Okay, so you see the denominator we always try to split them into factors, right? Now obviously, in this case, this is the denominator. It has two factors. Quite clearly, there are two factors, right? So we split it into one factor and the other factor. Now, you need to ask yourself, can your x be further separated into two different factors? Cannot already lah, so that's it already. What about your 2x squared plus 1? Can split into two other factors? Can or cannot?
Repeated.
It's not repeated. Can split some more or not? Can. Split into what? It is a quadratic factor, yes. But in this case, this quadratic factor cannot be factorized anymore already. Okay? You cannot separate it out further. So the numerator will be degree of the denominator minus 1. Okay, you check our textbook, there are three cases. If the denominator is linear, for example, x, numerator is a constant. If the denominator is quadratic that cannot be factorized, numerator is linear, which is ax plus b or bx plus c, cx plus d, whatever. Okay? Now, what is the third case? The third case, the denominator is repeated. When the denominator is repeated, there will be another way to separate them, which is found in this one. So if I have time, I'll go through this. So now, you need to know, you need to be able to write this down. Your job now is to find out the values of a, b, and c. How do we do that?
Multiply throughout
What do you mean?
with the original equation.
With the original equation.
Yeah.
So what will you write?
Multiply throughout x bracket 2x squared plus 1.
X bracket 2x squared plus 1. Okay, so you mean x bracket 2x squared plus 1, multiply this to the original, 2x cubed plus 3 over x 2x squared plus 1 equals to everything over here, x 2x squared plus 1, 1 plus a over x plus bx plus c over 2x squared plus 1. Is this what you mean? Is this wrong? No, it is correct. There is nothing wrong with this. Is there an easier way? Maybe lah. Okay, but this is not wrong. This is not wrong. So now I'm going to do it based on this approach. Do you see that? Do you see why I say this is correct? I just multiply by the same thing on both sides, right? Naturally, they must be equal lah. But what's the point of doing that? X cancel x. 2x squared plus 1, 2x squared plus 1. Done. And then on the left hand side, I'm left with 2x cubed plus 3. Am I right? On the right hand side, now, this whole chunk multiplied by 1, what do we get? The same thing, x 2x squared plus 1. Then, now I multiply to this one, what do I get? A
Bracket 2x squared plus 1.
plus 1, okay. Now it is multiplied to this part. What do we get?
Bx plus c bracket another thing and x.
X. Is this correct?
No, no, bracket the bx plus c.
Yes, you see? I keep giving you all the common mistakes that you may make, but you all don't seem to be able to catch it. Okay, now, we arrive at this. Sihan, is this what you wanted to write straight away? That means without writing all this, did you want to write this straight away already? Yeah, okay, so yes, what is the reason behind us being able to write all this down straight away? Because of the part in black. Alright? So if you can do the part in black mentally, straight away go to the next step. Okay? Now, what shall we do? I need to find A, B, and C. Okay? So, since we have this equation very nicely laid out over here, a test question could look like this, with the 3 equal sign. Okay, and then ask you to find A, B, C lah. So your steps are still the same. Okay, so I'll just revert it back to the original. Okay, so how do I find A, B, and C? Let x equals to
2x cubed plus 3.
2x, let x or let fx, okay, 2x cubed plus 3. Okay, then what do we do next? 0. Okay, which one do you want to make equal to 0?
2x squared minus 2x squared minus
Can or not? 2x squared plus 1 can equal to 0. Oh yeah. 2x squared plus 1 is always greater than 1. Equal to 1 or greater than 1. So what else? X equals 0. Okay, let's try. F of 0 equals to this one on the left hand side, I get 3. At the same time, it is also equal to 0. 0. I get A times 1, right? So A equals to 3. Okay, then what should we do for others? Find the other unknowns. Now this is 3 already. Okay, what do you want to do next?
Sub in first.
Sub what? Okay, I sub in already. 3. What else? X equals to? X equals to 1, okay. Will anything disappear if I do that?
No.
No, right? Because you have no choice already. Nothing else is going to disappear. Now is the time for you to randomly choose number. Choose something convenient lah. Okay, so F1, we get 5. At the same time, it is equals to 1 times of 3 plus 3 times of 3 plus B plus C. Correct? Okay, so now I have an equation. B plus C is equals to 5 minus 3, which is 2, minus 9, which is negative 7. Okay, this is my first equation. Then when students see this, right, then stress already. I only got one equation, how to find 2 unknowns? Choose another one. F of what would you like now? 2. Okay, 2 negative 1. I personally prefer negative 1. Okay, because negative 1 is easy to deal with. Then you get your value of A, B, C. Substitute them back inside, get the answer. Okay? So last question. 60D. Again, partial fractions. What is the first step? What's the first step? Come on.
Divide long division.
Why long division?
Improper fraction.
Because it is an improper fraction. Degree in numerator equals degree in denominator. Okay, do your long division. 2x cubed plus 0x squared plus 0x plus 4. Here we've got x. Wow. Okay, let us expand. The denominator, I'll just do it at the side. X times of x squared plus 4x plus 4. X cubed plus 4x squared plus 4x. X cubed plus 4x squared plus 4x. So 2x cubed plus 8x squared plus 8x. Subtract it off. We get negative 8x squared minus 8x plus 4. Oh, okay. It's just a habit lah. Okay? Can? What? Is this what you all do? Number 4, okay lah. Actually, it doesn't matter lah. Okay? This part really doesn't matter, but I at the start I told you all to put it in the correct place, right? Yeah, so you can go ahead and follow that. Okay, so now this is equal to, what is this equal to? 2 plus negative 8x squared minus 8x plus 4 divided by. Okay, now I am no longer interested in all your little workings. I want to know how you will change this to partial fractions. 2 plus what?
2 plus a over x plus b bracket x plus 2 over x plus 2 plus c.
Plus C ah?
No, bracket.
Oh, okay.
Plus c bracket x plus 2 square.
Like that? Okay, very good. So from here, can you get your A, B, C yourself?
Yes.
Can and then everything correct already? Now, what is the difference between this question, specifically this part, and the previous one?
The previous one is quadratic factor.
Yeah, quadratic factor. I also have a quadratic factor here.
Cannot be repeated linear factor.
This one is repeated. It can be factorized, right? This one cannot factorize. Okay. Any other questions? We've got 2 minutes left.
Mr. Wong.
Yes.
Page 15.
1-5.
Yes.
Yes.
Question 8C.
6x cubed minus 11x squared plus 6x plus 5, ax minus 1, bx minus 1, x minus 1 plus c. Okay, class, what do you want to sub into x?
1.
Let us sub 1 first. When you sub 1, all this becomes 0. So you get c. Okay, c is done. What do you want to sub next? What do you want to sub next? X equals to? Can we sub in 0? Yeah, we can sub in 0. But when you sub in 0, this one disappear, 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 disappear. And then you are left with C only one, which is what we are trying to find also, right? So sub in 0 doesn't help. What else can we do? Can I really sub in anything I want? Just go ahead and sub in. You can expand, yes. It could be very tedious. Knowing that I've got a value of C already, I will want to sub in f of 1, for example. Then I will get equation with A and B. C is already found. So I want to sub in what next? You can sub in 2. How about, wait. Sub in 1 doesn't work. This will become 0. I will sub in negative 1. Then I'll probably sub in 2. 0 doesn't work also. Okay? So we get A and B in the equation. So equation 1 and equation number 2, solve. Get the answer. Okay? What is the first topic in A maths that we learned? No? Simultaneous equation. Do you remember how to do it? Which method will you use in A maths? Okay, so simultaneous. Use substitution. In A maths, because elimination may not always work in A maths, but substitution will always work. Okay, that's it already. Any final questions? If there are any, you let me know. I'll work it out. I'll put it online. Are there any? 5, 4, 3. Yes. Mentor page 22. Question 55. Okay, any more?
Mr. Wong, my own book have
Practice. Like this. Okay, any more? Alright. 7. Page 72, mentor. Like this? Okay.
So, it's not from any book your side.
Take a picture, send it to me. Okay, that's all. Class 10. Thank you, class. Have a nice day. If you don't want to remain at the bottom, please work for your test tomorrow. Yeah. Yes?
Yeah, I want to ask about this one, where I can use this as, because it's so far it's from polynomials to partial fractions. So it's like chapter 1, can you use it as a reference?
You want to use but you're not going to bring it during the test one.
But then I might use working that you never teach.
If it makes sense, if it works, I will give you the mark one. But if it is rubbish, then I will give you a mark.
Okay, right, thank you. come, let's go.